Hi, this is feedback for question 3 on the How Fast homework. This is to do with the reaction between propanone and iodine. We're measuring the rate of reaction using a continuous method. We remove portions of the reaction mixture at known times and then perform a titration on that mixture using sodium thiosulfate. So a standard solution, so we know the concentration of this solution. And sodium thiosulfate is a chemical, is a reagent that you'll become more familiar with during book 4. So for now then, sodium thiosulfate formula is Na2S2O3, and it's a solution, which means it will dissociate into its ions, so 2 sodium ions and then this one here. And this one is called the thiosulfate ion. Okay, and the thiosulfate ion will react with iodine. And this is going to be a very familiar reaction to you by the time you've done book 4, because this is in fact a redox reaction. So just want to prove to you that it is redox, but let's have a look at the equation first of all. Okay, so you've got this in your notes, so you might well have just copied that out at the moment, but let's just prove that it is a redox reaction that's happening. So if we take the thiosulfate ion, that's changing into this one here. Okay, that's called a tetrathionate ion. You don't need to remember that name. Okay, so let's have a look at the oxidation numbers. Each oxygen atom in there has an oxidation number of -2. So there are 3 of those, so -6 altogether. And all the oxidation numbers must add up to the charge. So 2 minus charge, so an oxidation number of -2. So what does this have to be? Well, to make that sum work, this number has to be +4. But that's shared out between 2 sulfur atoms, so each sulfur atom has an oxidation number of +2. We have a look over here then, same rule applies for the oxygen. Each oxygen atom has an oxidation number of -2. There are 6 of them, so -12 in total. Everything adds up to the charge, which means that our question mark here for the sum to work has to be +10. That 10 needs to be shared out between 4 atoms, so each sulfur can have an oxidation number of 2.5. Now you can't really have half numbers for oxidation numbers, so we can just consider that as an average. So each atom then, if you will, when it changes, well, we need to balance this first. There's 4 sulfurs, so we're going to need 2 moles of the thiosulfate ion. Now each of those atoms of sulfur will change by a half. It will increase by 0.5, so there's 4 of them, giving you a total increase in oxidation number of 2, so +2. We have a look at the iodine then. Iodine has changed from I2 to 2I-. The oxidation number in the element then is 0, and here it's -1. So there are 2 of them. So the total change, which is a decrease this time, the total decrease is -2. So that balances as well. Okay, so we've got an increase, which is oxidation, a decrease, which is reduction. So together, that's a redox reaction. Okay, so the reason why that this is such a famous reaction, if you will, is because we can do a titration using an indicator, which will be a starch indicator, and the starch indicates for iodine. So when iodine is present, the starch will appear as a blue-black colour, and when all the iodine is gone, in other words the thiosulfate has reacted it all away, it changes quite sharply to give a colourless solution. So it's got a nice sharp end point there. Okay, so we'll come back to that reaction again in book 4. So let's have a look at the rate information now. So we've been given a table here. So let's just cover this up. Okay, so we're asked now to work out the rate equation. So I've numbered the experiments 1, 2 and 3, so it's clear which one I'm talking about. We're told that the concentration of H+, the reaction is first order with respect to the concentration of H+, so we need to work it out for propanone and iodine. So for propanone we need to choose 2 experiments which just the concentration of that changes. If we choose 1 and 3, then the iodine concentration stays the same. So tell the examiner which experiments you're choosing, so experiments 1 and 3. Okay, so the propanone, the concentration has doubled, 2 used to be 1. That stayed the same, so we don't need to write that down. And the rate has gone from 3.2 to 6.4 times 10 to the minus 3. If you weren't sure, then you could put that in your calculator, 6.4 times 10 to the minus 3 divided by 3.2 times 10 to the minus 3 to give you 2. Okay, so the rate has also doubled. So the relationship here is that it's directly proportional. So therefore we'd say that it's first order with respect to the concentration of that propanone. Okay, let's have a look at the iodine then. If we choose experiments 1 and 2 this time, then the concentration of the iodine has gone from 0.1 to 0.2, so it's doubled. These have stayed the same, and in fact the rate has also stayed the same. So by doubling the concentration of iodine, that has had 0 effect on the rate, so therefore it is 0 order with respect to the concentration of iodine. So we now know that the iodine will not appear in our rate equation. So a rate equation always begins rate is equal to K, and then we multiply then, so we've got the concentration of propanone. Now that was first order, we don't need to write the 1 because anything raised to the power of 1 is just itself, but we do need to multiply then by the concentration of the H+, which is also first order. So there's our rate equation there. Okay, and that's all they asked for on this occasion. 5 marks, pretty generous at this stage. You'd need to do more for 5 marks in the real exam, I would say so, but you must always, show you're working out in that methodical way, always stating which experiments you get the data from, what the evidence is, what your conclusion is, and then bringing it together in the rate equation.